Welcome to Hydro-Dyne Engineering's webinar series. The topic of this webinar is septage receiving and its challenges and screen technologies. My name is Tim Mathias. I'm a business developer for Hydro-Dyne Engineering. And Hydro-Dyne Engineering is a provider of wastewater treatment equipment, specifically screening and compaction technologies. The scope of this presentation covers the challenges around septage receipt, the impacts from inadequate technologies, the purpose and benefits of septage receiving technologies. I'd like to cover some design considerations. I'd like to also cover a technology summary of screens available, as that is the base of the system, and then we'll wrap it up. So starting, septage can be argued as the toughest waste stream to a treatment plant. There are 21 million septic systems in the United States. These are highly variable in composition. They can have high solids content. There can be a lot of fats, oils, and grease, commonly known as fog. And these can have high rag content. And what happens is a septic hauler has to show up and pump out each individual tank and then haul that back to a treatment facility. Looking more deeply at septage composition, the total solids can be as much as 50 times greater than typical wastewater. The total suspended solids can be as much as 50 times greater or more of typical wastewater. The fats, oils, and grease content can also be greater, as much as 100 times, and the nutrient level can be as great as 30 times more than typical wastewater. I'd like to cover challenges with septage receiving. The composition is variable in terms of rags, fats, oils, and grease, and the solids type and composition. When a hauler truck shows up to a site to offload into a treatment plant, the initial flow is by gravity from the tanker. This creates a high flow across the screening system that can have high solids and can potentially blind the screen. As the hauler truck empties, flow goes down as the level goes down near the empty point. And as flow goes down, the velocity drops in the pipe, and low velocity can drop grit into the septage receiving system. Rocks are also contained in these systems, and that comes from pump outs of lift stations that contain grit and rocks in collection systems. So those heavy objects can impact septage receipt. Tanker unload speed is required. When a hauler truck pulls up to a site, they generally want to unload the contents of the tanker and then get back out of the treatment facility. So screening speed and compaction speed are things that are important in the process. Sometimes the septage receiving system is in a hazardous area within a treatment plant, so intrinsically safe design is needed. The screening system and septage receiving system has to have impact resistance, and that's because of the rocks and grit that can be in the system. The screening and septage receiving system has to be corrosion resistant to hold up to biogenic corrosion. And ultimately, we have to run the system without overflowing the tank, so we need good controls. And there can be hauler access needed with septage receiving, and that controls who can show up and how much they can potentially unload into the system, and then track what kind of waste is received. I'd like to cover the impacts from inadequate technology. And that ultimately gets to upset haulers. The system is there to make sure that the haulers can unload their liquid waste and then go out and get more liquid waste to bring back for septage receiving. So things like blinded screens, down compactors, damaged screens, or any type of manual cleaning needed in the process are looked poorly upon. This means anything that slows the haulers down, like equipment failure. So the more robust a screening and compaction technology is, the better it can hold up and then process the septage as it comes into the plant so the haulers then can move on. This also gets to revenue. In most cases, septage receiving is a revenue source for the treatment facilities. So if that process is slowed down, then the revenue source is slowed down. So the key factor here is speed, to let the liquid waste haulers do their job and then move on and provide more liquid waste. I'd like to cover the purpose for a septage receiving station. The purpose is to remove inorganic solids greater than 6 millimeters. And this is trash that gets into the septage systems. So we're trying to control the inputs to any treatment process. The benefits include we're preventing fouled pump internals downstream, we're minimizing pump impeller wear, we want less or no debris floating in any downstream clarifiers, we're minimizing any fouled aeration systems that could potentially happen downstream, and in general we want less inorganic trash in the wastewater sludge. I'd like to cover design considerations for a septage receiving system. The first is speed. We'd like to be able to unload a large truck in under 10 minutes. We want to be able to handle many liquid waste hauling trucks per day without shutdown or any type of manual intervention. We want to integrate a screen compactor into a tank with a control system such that they all work together. We want best screen hydraulics. That means a screen that can handle high flow conditions at the beginning of an unload process and low flow conditions that happen at the end of the unloading process. We want a screen with a good grid that can hold up to the heavy objects that are present. We'd like to have a dedicated compaction system. That means that any heavy objects that get in there can move through the compactor and be removed from the system. We want to be able to screen waste with high solids content and high, potentially, fats, oils, and grease content. Then we want to be able to offload that screen with high solids such that it's cleaned and then can be used again. We want to eliminate any wear items in the design if possible. That means potentially blades, brushes, or rakes that can bind up with high solids or rag content and ultimately wear out. We want to eliminate any in-tank maintenance. We don't want people in contact with the septage itself, and we want to have things like auto flushes that wash out the system. We want to eliminate any manual cleaning needed, and we also want to try to integrate a rock trap into the design, such that any heavy objects that get in the system are conveyed out to the compactor and then removed. And then we also want auto wash features such that grit that is in the system can be cleaned out. I'd like to cover the septage receiving process in a little bit more detail. This begins generally with a hauler access panel that allows a liquid waste hauler to have access to the system and can generally control who and how much waste are offloaded into the system, and that generally includes some type of shutoff valve and flow meter. There is also software that is connected to the hauler access system that can allow billing to happen. The next part of the process is the screening and compaction system, and that then is connected to a main control panel such that the waste is screened and solids are removed and compacted from the system. And then there can be a local control component for the screen and compactor, as those can be located indoors in a hazardous area. I'd like to cover the technologies present for screening, as screening is the heart of a septage receiving system. So we're going to cover different screens: spiral, a drum screen, and a through flow screen. And we're going to look at things like how they work, what their grid types are, what are the screen unloading methods, if there's a conveyor or compactor present, what are the footprints available for each? Are heavy objects addressed in each design, and what are general maintenance requirements? Now, these aren't all the designs available. I'm covering the main technologies that are used for septage receiving. The first screening technology I'd like to cover is a spiral screen. The spiral screen utilizes an auger against a stationary plate. The auger is used to convey solids and clean the perforated plate and convey those solids into a compaction zone. The grid type here is a stationary, circular, perforated plate. The screen unload method is the auger, and the auger is used with a brush to unload the screen. The footprint is generally higher as the screen sits at a low angle and requires more space. There generally is need for heavy object removal as part of a spiral screening system. And I'd like to cover the maintenance requirements. The grit load can cause high wear on the stationary grid. Motor replacement requires generally a crane or a platform as the motor sits higher than 6 feet. And manual cleaning is generally required on these types of grids over time. The next screening technology that I'd like to talk about is an inclined drum screen. So an inclined drum screen, as the name connotates, utilizes a cylindric drum that rotates. And as it rotates, there's a catch basin mounted in the center to catch screenings, and then there is a conveyor located within that catch basin to move those screenings to a compactor. So the grid type here is generally a perforated plate formed into a cylinder. There can be a separate motor needed on the cylinder for rotation, and then a separate motor for the conveyor compactor section. The screen is unloaded typically with a brush or water offload into a center screw, and that is the conveyor compactor section. The footprint on these types of screens is generally larger as the screen sits at a low angle. These screens can operate without heavy object removal in front of the screen. And I like to cover the maintenance requirements. An auger motor is typically at higher elevations in these designs and can generally require a crane or a platform. And manual cleaning is expected on some basis, but less so than the spiral screens. The third type of screen I'd like to cover for septage receiving technologies is the traveling band screen. The traveling band screen utilizes a linked bar grid to convey solids to a compactor. So the grid type here are stainless steel bars. These types of systems are generally offloaded by water directly into a compactor. There is no screw conveyor on this type of screen. The footprint here is generally lower as the screen sits at a higher angle. These types of systems generally do not require heavy object removal before the screening system. And a little bit about maintenance. The bar screen can hold up better against the heavy objects and grit load present, and manual cleaning is not expected for this type of screening technology. I'd like to briefly cover technologies available in terms of screening for septage receiving systems with a few notes. Looking at categories like hydraulics, the bar screens generally tend to perform better at the high flow and low flow conditions that can occur in a septage receiving process. The bar grids hold up well against the high grit and heavy objects that can be present in septage receiving. One nice feature is a dedicated compactor motor. In that way, the compactor can be built in a more heavy fashion to last longer. Some designs do not require separate rock traps. The rock trap can be integrated in the drum screen design and the through flow design. Screen unload methods are important. The drum screen and the through flow designs utilize water to clean and unload the screening system. The small footprint is generally best in the through-flow design as its screening angle is highest. And looking at life cycle costs, the bar-type grids hold up better over time and require less maintenance. And I'd like to talk a little bit more about that on the next slide. I'd like to cover life cycle cost. Life cycle cost amounts to the total cost of ownership. Life cycle cost is a good method to evaluate a septage receiving system. And life cycle cost generally includes a capital cost and an O&M cost over a time period. And generally that time period is long and can be 10 to 20 years. So this is an evaluation that looks at capital, and that can be equipment, design, and construction all wrapped in to a capital cost. And then that's added to an annual maintenance cost and a replacement parts and labor cost to come up with an overall life cycle cost. The annual maintenance cost can include things like inspection, unit cleaning, rock removal, gear oil change, any of the maintenance items that are present in the system. Replacement parts and labor cost includes things like motor replacement, brush and rake replacement, any types of chains or grid sections that have to be replaced. These two items with O&M are annualized, added to the capital to come up with a total life cycle cost. And that then is used to evaluate the septage receiving process. And I'd like to summarize some of the major points. So septage waste is much tougher to treat than typical wastewater. We talked about the solids content and rag content that can be much higher than a typical wastewater stream, and that can blind the screening system that is the base of a septage receiving system. Some other key points include the ability to offload the most septage trucks with the least downtime in one of these systems. And that means reducing any O&M labor, any operation and maintenance labor, keeping the system up. We want a system that can operate automatically with very little intervention. We want good equipment life as part of a septage receiving station, something that requires very little maintenance over a long period of time. And ultimately what we're trying to do is maximize the revenue to a wastewater treatment plant as they receive septage loads into a plant. That ultimately maximizes hauler profits to be able to unload many trucks, unload them quickly without manual intervention so that they can be on the road and bring back more liquid waste to a treatment plant. That ultimately leads to happy waste haulers, happy customers. So I'd like to provide some contact information so that you can come back and feel free to ask us more questions. Hydro-Dyne Engineering is located in Clearwater, Florida. Please feel free to call us or email us, and you can do that to me personally. And we also have a website that has more information. We welcome visitors. Thank you.